Today we're studying about lines and surfaces. Mostly in our syllabus, some equipotential surface has more weightage. Lines I'll tell you basic. So first we'll look what are equipotential lines. Okay. So equipotential lines are basically lines along which potential is constant. Means when we move along the equipotential lines, the potential remains constant. Okay. And equipotential surface, they are basically a 3D version of equipotential lines. Okay, 3D version of equipotential lines. Okay, EL equipotential lines. This is equipotential surface. Okay. Another definition of equipotential surface can be for a given charge distribution, uh, locus of all points having same potential. Okay. Potential, right? This is another. This is another way you can define equipotential surface. Okay. Uh, so have you got this? That equipotential surfaces are basically the surfaces on which every point has same potential. Okay. Now we'll talk about shapes of equipotential surfaces. Okay. Uh, the first one for a point charge. Okay. For point charge, how does the shape of equipotential surface looks like? Suppose this is a point charge, right? Then the equipotential surface shape would be something like this. Means a sphere. Okay. Concentric spheres. Okay. They are what? They are equipotential surface for the point charge. Why? Because potential at this point, potential at this point, potential at this point, potential at this point, if they are a sphere, okay, will be what? Same. If this is if they are of radius r, let's say, okay, then potential at the surface will be what? Will be kq by r. Okay. Kq by r. Okay. So, and if you go from this point also has what? Radius r. This is also radius r. This is also radius r. This is also radius r. So there will not be change in potential. It will remain constant along this surface. Okay. Similarly, this is what? Another equipotential surface. This is what? Another equipotential surface. Okay. Then for a point charge, equipotential surface will look something like this. Okay. And this is what? This is direction of electric field, right? The next for a line charge. Okay. For a line charge, let's say drawing a line. Let's say this is a line. Okay. Having point charge. Oh, sorry. Having linear charge density lambda. Okay. Then the equipotential surfaces will something look like this. Okay. Means a cylinder, cylindrical shape. Okay. Why? Because you know that potential at a distance r due to a line charge will be same for here. Okay. Because it only depends on what? The radial distance. Okay. It will be same for here, same for here. Okay. And same for here. Okay. So this curved surface, okay, curved surface of cylinder will be what? It will act as equipotential surface for line charge. Okay. Third, you need to show equipotential surface in electric field. Okay, for uniform electric field, you can say. Okay. For uniform electric field, let's say this is electric field here. You know that equipotential surface are, or sorry, potential decreases along the lines. Okay, so equipotential surfaces will be something like this, means perpendicular to this electric field. Okay, in the plane perpendicular to this electric field. Okay, they will be what? Equipotential surface. Okay, means potential on them will be what? Constant. Okay, for uniform electric field. Okay, now we'll look at properties, few properties of equipotential surface. The first one, uh, equipotential surfaces are always perpendicular direction of electric field. I've told you. Okay, perpendicular to electric field direction. Okay, the second point, you can say that equipotential surfaces never intersect. Okay, the third thing you can say that if let's say this is equipotential surface, and if a charge q is moved from here to here, okay, then there will not be any work done. Work done will be what? It will be zero. Why? Because delta v is zero. Because potential is constant, so delta v will be zero, and delta v will be zero. So work done will also be what? It will also be zero. Okay, means there will not be any work done if we move a point charge from one point to other point in equipotential on equipotential. The fourth point, you can note that electric field intensity, okay, remains constant on equipotential surface. Okay, means if this is electric field intensity, then electric field at this point, electric field, this is a, consider it as a sphere and point charge q is placed here. Okay, electric field intensity at this point, at this point, at this point will be same. Okay, there will along equipotential line surface, electric field intensity will always be constant. So these were four basic properties and introduction about equipotential surface.